All right, we're going to find the shortest path in this diagram. We're traveling from A, the initial vertex, all the way to E over here. That's the path that we're traveling. We want to find the shortest possible path to get there. Now, what's the shortest path? The shortest path is when we take the weighting of each particular edge and it is all the weights are minimized. And here, these weights are distances and they're all in meters. So we want to find the minimal distance to go all the way to E, beginning at the vertex A. Now we're going to use Dijkstra's algorithm. It's a precise series of steps, and what's involved is we're going to have multiple candidates and we're going to compare them to find the best possible route, each candidate which is the lowest possible. So we're going to look at a variety of routes so we can put in the minimum possible in these vertices right here. Now, if you get a diagram that doesn't have the circles in here, then all you have to do is redraw it and you put in the circles yourself so you can use Dijkstra's algorithm. And that's all about filling in these vertices in these circles as we accumulate and get closer to E, which is what our outcome is. This is kind of similar in minimal spanning trees, except it's like Prim's algorithm. And this one's different, of course. We're looking for the shortest path. So let's begin. Let's find the shortest path. First of all, we're going to work one edge away from the vertex and then the second edge and the third edge until we finally get to E. So let's work with the first edge. The first edge away from A, the beginning, we're going to put 0 next to that because the distance from A to A is 0. So now let's go from A to B. Let's find the minimal distance there. So we got a direct line here of 12. So let's provisionally explore that 12 and compare it to another path. Another path may be we can go A to I to B. So let's see what we get here. It's 5 plus 6. 5 plus 6 is 11. Now, is 11 less than 12? Yes, it is. Therefore, the shortest path actually is this way, not directly there. So let's put in the 11. 11 is shorter. So you put the 11 in that vertex right there. Let's explore now A to I. Let's look at the likely paths. We've got A to I, 5 directly here. Or we could get here, we can go 7 and 8 to get there. Now 7 and 8 is 15. That's a lot more than 5. So it looks like 5 is going to go in there. So I'm going to put a 5 in there. There's our 5. Looks a bit like a 6, but it's a 5. Okay, it's a 5. All right, next, let's go down here. It's one edge away from A. So directly right there, we got 7. We don't want to do 5 and 8. That's too much. So 7 directly there. So we'll put a 7 right there. So there's the shortest path to the first vertices. So that's what we do first. We get one edge away from the initial vertex. Now we start going 2 edges away from the initial vertex. So let's have a look at this one here, G. Let's explore this one. We want to go from H to G, and we've got a 7 here and a 10. If we add them together, 7 plus 10, that's going to give me 17. Let me put that down provisionally, 17. We're not going to totally go for it. We may find a better path. Let's try another one. Let's try A to I to G. So that's going to be 5 plus 7. 5 plus 7 is going to give me what? That's going to give me 12, isn't it? So is 12 less than 17? Yes, it is. So we go with the 12. So let me write that in. Shortest path is 12. There we go. 12. Let me rub these guys out now. 12 is less than 17. All right, let's continue here. We're going to go for this edge right over there. Now we want to go from B to C. Let's see what we get. Well, we got 11 in here. Let me rub that out. We don't need it. Okay, we got 11 plus another 11 here. To get to C, 11 plus 11 is what? 11 plus 11 is 22. Is that the shortest? Well, let's compare. Let's compare candidates. Let's try this. Let's go 5 and 6. 5 plus 6, that's what? That's 11. That's half of 22. So it looks like 11 would be the best one. So let's put 11 in there. Again, how did we get it? It's 5 plus 6 is 11. Let's look at this candidate right here. Let's look at and explore different paths here. So how can we get to J right over here? Well, we can go G to J. That means 12 and 10. That's going to give me 22. There's one candidate. Let's try another one. We could do 5 and 9. That gives me 14. 14 might work a bit better. Or we can do 11 and 10, that's going to give us 21. So it looks like 14 would probably be the lowest there, so we'll put a 14 in there. So let's put it in. 14 goes in there. Let's go to the next edge now. So the next edge is right here at F. Let's try 14 from J to F. So that means we take the 14 and add it to 12. 14 plus 12 is 26. Let's rub these guys out. So we got 26, that's one candidate, one possible route. 14, 12, 26. Let's try going directly across here. Can we get lower? 12 plus 8, what's that? That's 20, isn't it? Now is 20 less than 26? You bet it is. So we're going to go with 20. So 20 goes in there. There's our 20. Okay, let's find this candidate here, number D. Now we can go C to D. All we have to do is add 11 and 13. 11 and 13 is 24. 24, let's rub these guys out. I don't want them to distract. We've got 24. 11 plus 13 is 24. Well, that's okay, 24. Let's see if we can get lower, a shorter time span. We've got 20 here. Let's go up to D. 20 plus 2 is 22. Now, 22 is less than 24, so let's do 22. Let's put that in here. 22. Okay, we have 22. Now we want to get to E. There's two paths, that way and that way. Let's explore both. First, I'll rub these guys out. Now, we can go directly across. 20 plus 5, that's 25. 25, is that going to work? 25 meters. Well, let's have a look at a better one. Let's try this. Let's go 22 right here and add 2 to it. 22 plus 2, that's 24. Is 24 less than 25? Yes, it is. So we put 24. So that's what goes here. 24. There we go. So the shortest path from A to E is 24. 24 what? Because all units are in meters. It's 24 meters. So let me write that down here. 24 meters. That's the shortest path. Okay. 24 meters. Now, what's the actual path? Well, what we do is we work backwards to identify the specific path that we traveled along to get that 24 meters right over there. So which way did we go? So let's go backwards. So we've got 24 here. We went back 2 to 22. So we're going to go back here. So it's back this way. There. So there's our path along there. So we went to 22. From there, which way did we go? We went down this way. We subtract 2, we go to 20. So it's along here, right there. From 20, how did we get that? Well, we went along here from G, didn't we? So we're going to travel along there, along here. So we traveled along from F to G. Now, how did we get that 12? How did we get it? It was 7 plus 5, wasn't it? 5 and 7. So we're going to go up here, aren't we? So it goes up along here, along there. Let me just emphasize it. There's our path from G to I. From I, how do we get the 5? Straight across to A. Here we are, right there. There's our path right there. Okay, we've identified our path. A to I, to G, to F, to D, to E. That's our path. So let me just write that all out here. So let me just clear this over here. All right, let's write it out. So we went A. This is the shortest path, the route A to I, to G, to F, to D, D to E. And that is our shortest path. Let me just box that up. So our shortest path is AIG, FDE. And altogether, it's 24 meters. There you go. Hope that helps.